Chapter 9, question 74. Tamika heard that the diagonals of a rhombus are perpendicular to each other. Help her test that conjecture. Graph quadrilateral ABCD on a coordinate grid with A at 1, 4, B at 6, 6, C at 4, 1, and D at -1, -1. And you can see that I've gone ahead and already graphed that. So you can see these are the exact points that they asked me to graph. And I think I'm going to go ahead and add the lines that connect each of those to make the quadrilateral. So you can see I've drawn the lines here, and it certainly looks like a rhombus. Of course, the problem is that I don't really know if it's a rhombus. So one of the things about a rhombus is all four of the sides have to be exactly the same length. So let's investigate that, if the sides are indeed the same length. I'm going to grab a red pen, and I want you to consider this little right triangle right here. And on this right triangle, one of the sides is the side of a rhombus. And if you look at it down below, I've got it 2. It is a right triangle. And up here I've got 1, 2, 3, 4, 5. So you can see I've got 5. Now, according to the Pythagorean theorem, right, the length of BC, the length from point B to C, would be 5 squared plus 2 squared, which is 29, and that is what that BC squared would equal. But BC itself, the length of segment BC, would equal the square root of that. So I've got one of my sides is this length root 29. Now, without doing that for all the sides, I just want to point out that, for example, I'll grab a green pen for this one. I've got this side right here, it's got a 2. And right here I've got 1, 2, 3, 4, 5. So you can see 1, 2, 3, 4. I got a right triangle with a 2 and a 5. And let me grab a yellow pen. Right here, let's see. Ooh, where am I going to draw this one at? I could draw it here. Right here I've got this. No, why is that a highlighter? I don't want that. Let me get a blue pen. I got this 1, 2, 3, 4, 5. And that's a 2. So again, this side from A to D also is the hypotenuse with the right triangle of 5 and 2. And then the last one, I can also draw this right triangle here. It's 1, 2. It's 2 down there, and you can see on this side it's also 5. So what I've been able to do here is by, pointing each of these out, I have 4 right triangles. All those right triangles have a hypotenuse that's a part of the rhombus. And notice that they all 4 of them have a leg that's side 2 and a leg that's side 5. So every single one of those sides is exactly the square root of 29 long. So I have a quadrilateral ABCD. Oops, that's off screen. I'm writing. ABCD has 4 congruent sides. Now, part of the problem is, I just verbally said that. I didn't actually show all of the sides. And probably if I was writing kind of a formal proof here, I was kind of being more formal with this, I would write all of them. In fact, let me just pause the video for a minute and I'll write off the 4 other things I would include. So if I'm being a little bit more precise here, you can see that I've written down that BC, AB, AD, and CD all are exactly the square root of 29 units long. So by definition, this is definitely a rhombus. Let's get back to the original question. It said, Let me zoom out a little bit. So we're testing up this conjecture that if you have a rhombus, then the diagonals are supposed to be perpendicular. By the way, in A where it says show how you know, show how I know that that's a rhombus, that's what I did over there. I was showing you that all the sides are exactly the same length. And in each case, I'm just kind of looking at these right triangles and using the Pythagorean theorem. So I've got 4 congruent sides, and I showed you how over there to the right. Now it says find the equation of the lines on which the diagonals lie. That is, I need to find the equations that go through 2 different points. One of the equations goes through points A and C, and the other equation goes through the points B and D. So let's come back over here and look at this. So I need to find 2 equations, and it turns out it's the equations of the diagonals. And you can see that one of them, I guess I'm going to write this down below. Let's go ahead and find the equation for BD first. So, whoops. So if I'm finding it for BD first, I'm going to be going from -1 to 6, 6. So I've got this point -1, comma -1, and the other point is the point 6, comma 6. So with those 2 points, my goal right now is to find the equation of the line that goes through them. And I'm going to go ahead and do that by finding the slope. So the slope that goes through those lines is the change in y's over change in x's. So if you look at my y's go from a 6, and then I'm going to go minus 1. So if I look at this, here's my y value, and here's another y value. Y starts at -1 and goes all the way up to +6. That's a change of 7 full units. And I can see that it's going 7 full units. And the other one starts out at, it's the same, right? It starts out at -1 and goes all the way up to +6. So I'm just going to take this second one, 6 minus -1, and that's also a change of 7 full units. So my slope here for this first line is 1 unit long. Now it asked me to find the equation of this line. So I only have the slope. I need to find the rest of it. So in order to find the rest of the equation, I'm going to go ahead and use either one of these points. I'm going to use 6, 6. Point x is 6, y is 6. And I'm going to write down y equals mx plus b. For this particular line, if I'm using 6 as my point, y would be 6, right? We've already found that the slope is 1 unit. X is 6, and my and b rather is, and plus b, I don't know what b is. Now, when you look at this, right, if I subtract 6 from both sides, right, 6 equals 6 plus b, I get that my y-intercept is 0. So I know the equation of the line that goes through the points CB. The equation of the line that goes through CB is y equals x. It's just y equals x, right? I could have looked at that and kind of figured it out, I guess, but that's the equation of that line. And notice what the slope is, and notice the y-intercept. We're going to do the same thing now for the other line, and this one, let's see, this one's going through 1, 4, and 4, 1. Let me write that down. One of my points is 1, 4, and the other point is 4, 1. So we're going to do the same exact thing, and except we did CB, so now this is was that C? No, that was CD. I'm sorry. That was the equation of the line that went through CD. We're going to do this now for the AC. Okay, so now I got this all backwards. This was C. This was BD. I'm sorry. BD. Now we're going to do it for the equation of the line that goes through AC. So you can see I've got my points A and C here, and we're going to come up with the equation of the line that goes through that segment, or includes that segment. So I'm going to again begin by finding the slope. My slope if you'll recall, is the change in my y values. So I'm going to again start from the second one. I'm going to call this my second point. I'm going to have 1 minus 4 in my numerator. And in my denominator, this time I'm going to have, I had 1 minus 4. Now I'm going to have 4 minus 1. Now when I simplify that, my numerator is a negative 3 and my denominator is a positive 3. So I have my slope equals negative 1. Let's see, the other thing that I need is now that I know the slope, I need the y-intercept. So I'm going to use the same trick I used up above. I'm going to write the y equals mx plus b. My y value for this point, I'll use the point 4, 1. Or I'm sorry, x is 1, y is 4. So I'm going to put down that y is 4, and that equals my slope of negative 1 times my x value, which is let's see, x is 1 plus b. So what I have right here is y, or 4 rather, equals negative 1 plus b. Therefore, b would have to equal the number 5.